So this lecture, we're going to take a look at another voting system, something called the Plurality with Elimination Method. And this is kind of an interesting one because it's going to combine two of the systems that we talked about previously. It's going to combine the idea of winning by majority with a ranked voting system. And so the way this works, I've got a simple little set of voting results here for us to take a look at. The first thing we need to do is say, well, how many votes do you need to win by a majority? Well, if you add them up, there's 46 votes, 50% plus 1, that comes out to 24. Nobody has that many. And nobody has crossed that threshold yet. So what can we do? Well, take a look at poor Mark, sitting down there at the bottom with just 3 votes. Realistically, this guy is simply not a contender here, right? So what would happen if we removed him from the list? Right? How do things look then? That's the basic idea behind this plurality with elimination method. We're going to calculate the number of votes required for a majority. Then we're going to continuously eliminate the lowest ranked candidate until somebody ends up with that many first place votes. Okay, let's look at an example. Right, I've got, again, our preference table here. Different sets of candidates and the number of people that picked each of these arrangements. So, first thing we need to do is figure out how many votes you need to win. Well, 16 plus 6 plus 4 plus 8, that's 34. 50% plus 1, you need 18 votes. So far, nobody's there. Right? Nobody has that many. So what we do next is we just look at the first place row. Candidate B has the lowest number of first place votes. So that's the candidate that I'm going to eliminate from contention. Okay, so I'm going to go through the table, and I'm going to pick out all of candidate B's entries, and I'm going to remove them. Now, if you're doing this like on a quiz or a test or something, you can do this right here in the table. Cross out the B in column 1, put a C in that one. Cross out the B in column 2, put an A in that one, and so on. You can do this right here in the table, right, if you're writing this out. Because I have the option of doing it a little more cleanly, I'm just going to create a new table each time. So if we remove candidate B, in the first column, candidate C moves up into position 2. In the second column, candidate A moves up into position 2. The third column is the one that's really going to make a difference. Candidate C moved up into that first place position. And then in the last column, candidate B just disappears because they were in the last row. There's nobody below that to move into that spot. So now do the calculation again. Now candidate A still has 16 votes, but candidate C has 6 plus 4 plus 8. That's 18. Candidate C has met that 50% plus 1 threshold. Therefore, candidate C is the winner. Was this the expected result? Well, not necessarily. If you look back at the original table, candidate A was in the lead for first place with 16 votes. So what happened? Well, look at that third column with the 4 votes. Candidate A was ranked the lowest. Right, so you can see how the preferences matter here, right? Being the most disliked by just those 4 voters was enough to push candidate C up into the winning position. Candidate A being disliked was enough to move C up into the winning position. Okay, so let's take a look at another. This one is a little busier. There's more going on. We've got more assortment of votes, more variety in the rankings. Which gives us more columns. And we've got 4 candidates instead of 3, which gives us more rows. None of that is a problem. We're going to follow the exact same process. We just may have to do it more than once. Okay, step 1, how many votes do you need to win? Well, 16 plus 6 plus 4 plus 8 plus 10 plus 15, that's 59. 59 divided by 2 plus 1, that's going to be 30. Right? 59 divided by 2 is 29 and a half. The next integer after 29.5. That's our target, right? That's going to be 30 votes. So, has anybody made that threshold? Well, not yet. A has 16, C has 14, B is sitting there at 4 still, D has 25. So, we're going to do an elimination. B is our lowest ranked, it has the lowest number of first place votes. So those are the spots that we're going to get rid of. If we take all of those out of the table, push everybody up, we end up with this. Okay, do we have a winner? Well, A is now at 20, and A is the only one that changed. Right? A picked up 4 votes from that third column there. And that still wasn't enough to put them over the threshold. So we're going to have to eliminate again. Who has the lowest votes now? Well, A is at 20, C is at 14, D is at 25. So it looks like C is the one we're going to have to eliminate. So if we take out all the C's, push everybody up, we should have, one of two things should happen. Either we should have a tie, or we should have a winner, because we're down to 2 candidates, right? One of those 2 things is going to have to happen here. So if we update our table, candidate A now has 28 votes, so they're not the winner. They didn't make it up to 30. Do we have a tie? Well, no. D has 16 and 15. That's 31. D made it over the threshold. D is going to be our winner. Okay, so once again, there are some issues with this plurality with elimination method. I'm going to put off talking about those for a little bit. We've got one more voting method that we're going to talk about here, the so-called pairwise comparison method. Once we've done that, again, I said this at the end of the last lecture, once we've done that, we're going to circle around and talk about some of the flaws with this voting systems. And I think it's better to put that off until we have some voting systems to look at, because then you can actually see how those flaws occur. Right? We'll look at some specific examples of each one.